Alright, so we are here with the last question of the Mathematics Higher Level Paper 2 for the Khomas region in August 2020. So the last question here down at the bottom, question 14. Okay, so the diagram shows part of the curve y equals x plus 3 over x and the line y, I'm assuming that means y equals x for this line, x equals 3 and x equals 4 here. Alright. Calculate the equation of the tangent to the curve where x equals 1. So the tangent of a curve, we know that is a straight line. So that's going to be, let me just write down the equation of this curve first. Y equals x plus 3 over x. Okay, so y equals x, y equals x plus 3 over x. Alright, now the equation of the tangent is going to be a straight line, because tangents are straight lines. Mx plus c. Now to find this m, the gradient, right, that is the gradient. And we know the gradient of a tangent to the curve at the point where they touch, it's the same as the gradient of the curve at that point. So to find m, we need to find the gradient of this curve when x equals 1, right? So let's do this. To find the gradient, we need to differentiate. Okay, so let's first rewrite this as x plus 3x to the power negative 1. Just bring the x up, because that in polynomial form is much easier to differentiate. Alright, so now let's find the derivative. Differentiate this. So differentiating x, just you get 1. And differentiating this part, negative 1 times 3 is negative 3x. And then we subtract 1 from the exponent, so that's negative 2. And we can rewrite that as 1 minus 3 over x squared. Okay, but we want the gradient. So this is the gradient at any point for x. We want the gradient when x is 1. So we're going to say the derivative when x is 1 equals 1 minus 3 over 1 squared. And that just gives us 1 minus 3, which is negative 2. So far we know the gradient is negative 2. So y equals negative 2x plus c. Now to find the c value, we can substitute a point in. But what point can we substitute in? Well, we can find out what the coordinate is when x is 1. We already have one part of the coordinate. So we can find out what is y value when x is 1. So y equals 1 plus 3 over 1. So that just gives us y equals 4. So we have a point which is 1 and 4, which we can substitute into here. So the y value is 4 equals 2 times, and the x value is 1 plus c. So we can get 4. Oh, sorry, this is negative 2. My bad, negative 2. So this is 4 equals negative 2 plus c. So 4 plus 2, 6 equals c. So finally we have y equals negative 2x plus 6. And that will be our answer here. Y equals negative 2x plus 6. Great. Now find the area of the shaded region. Okay, so that's the little shaded region. So that's bounded. So that means I'm gonna write this down here and I'll just take it down to the bottom. So we're gonna integrate from 3 to 4. So from 3 to 4, underneath the curve of x plus 3 over x, x plus 3 over x. So that'll give us this whole area, right? This whole area. Then we're going to subtract from that the area underneath this straight line. So we're going to subtract from that this area. And what will be left will be the shaded area. So what is this curve? This is y equals x. So we're going to subtract that and do dx. Okay, so I'm just going to take this and bring it down to the bottom. So this is what we want to do to find the shaded region. Alright, so let's just rewrite this a little bit. So equals, integrate from 3 to 4. X minus x is nothing, so that's quite a bargain. We're just left with 3 over x dx. So I'm just going to rewrite that one more time. I'm going to take the constant 3 outside and integrate from 3 to 4. 1 over x dx. Okay, so that should look familiar. We've got 3 times, and then what is the integral of 1 over x? Well, the integral of 1 over x is ln x. Ln x. So when we have in general, if we have 1 over some linear function, let's say ax plus b, so that's linear because it has x to the power 1 is the biggest exponent for the variable, then this would become ln of ax plus b. So ln of the bottom part times the derivative of this part, which is a. Okay, so in this case, so that'll be ln x times the derivative of x, which is just 1. So that's fine, that's all we need. And we're going to do that from 3 to 4. Okay, so what does that equal? So if we substitute 4 in, we get 3 ln 4. And we're going to subtract that by, or minus that by 3 ln 3. 3 ln 3. Alright. And so that's our answer. And let's see if we put that in the calculator, what does that simplify to? So that'll be 3 ln 4 minus 3 ln 3. And that gives us that little thing here. Okay, so I'm going to copy that and paste it here. And then we just want to round that off to 3 significant figures as per the instruction page. So 0.863. Perfect. Okay, now question C, and that is the last question for the paper. Nice, we've made it. The region enclosed by the curve, the lines x equals 3 and x equals 4 and the x-axis. Okay, so let's see, what are we talking about? I'm just going to erase this for now. Okay, so the area enclosed by this curve, the line x equals 3 and x equals 4 and the x-axis. So this whole thing, that area, is rotated through 360 degrees about the x-axis. Find the volume. Okay, so this thing, so obviously if we look at it from the side, at the moment we see nothing, right? We just see this line. It's a 2D thing if we look from the side. But now we're going to rotate it about the x-axis like this, right? So you can imagine it coming out of the screen, going down and up again. So now if we look at it from the side, we see a circle, right? We see a circle here if we look at it from that side. So how do we find the area of a circle? Right, so the area of a circle, and yeah, this is a little bit smaller now. Let me do this. So this is what the whole circle will look like, right? Because it's going to be rotated through, so it's going to look something like that. So it's to be a circle that formed with a radius from here to there. That'll be our radius, right? And what is that value? Well, that's the y value of this curve. That's our radius. And how do we find the area of a circle? Well, that's pi radius squared. Okay, so what we want to do is we want to integrate, oh, that looks like an S instead of an integration sign. Pretty close though. From 3 to 4, because those are the starting and finishing points, right? Starting point 3, ending point 4. We want to integrate pi radius squared. So integrating area will give us volume. So this is what we want to do. Now, I'm going to rewrite this by taking the pi outside. Integrate from 3 to 4, the radius squared. But what do we know about the radius? We just saw the radius. The radius is the y value of the curve. So let's integrate by y squared. And then finally, we know what y is. So y is x plus 3 over x. So we want to take that squared, dx. Okay, so there we go. Now we've got our thing set up and we just want to perform the integration. So let's take this over here and start there. So we're going to say that's pi times, and then I'm going to square this first. I'm going to multiply that out. So x times x is x squared. X times 3 over x is just 3, but we do that twice, so that is plus 6. And then plus, if we square this, we get 9 over x squared. So 9 over x squared, I'm just going to write as 9x to the power negative 2. And we want to dx that. And we're still going from 3 to 4. So the next step is we actually do the integration. So this would be, if we integrate this, x to the power 3 over 3 plus, and 6, if we integrate 6, we get 6x. If we integrate this, we get 9x to the power negative 1 divided by negative 1. So divided by negative 1 just means we can make this, change this sign into a negative. Alright, there we go. And we want to do that from 3 to 4. That's what we're going to substitute in. So this equals pi, and then let's substitute in our 4. So 4 to the power 3 is 64 over 3. 64 over 3 plus 6 times 4 is 24 minus 9 over x. So that's 9 over 4. Great. And then minus, I'm actually going to do this, so I don't have to write pi again. And then we're going to substitute in 3. So 3 cubed is 27 over 3, which is 9, plus 6 times 3 is 18, minus 9 over x. So 9 over 3 is 3. Fantastic. Okay, so this gives us pi. And now let's work out the rest. So over here, I'm going to take a common denominator of 12. But I'm sure you can just type this in your calculator. You should get a nice answer. So this has to be times by 4. So 64 times 4. 60 times 4 is 240. 4 times 4 is 16. So 240 plus 16 is 256. Plus 24 times 12. Ooh, what is that? I'm going to work this out on the calculator. 24 times 12. That gives us 288. 288. Minus, and 9 times 3 is 27. Okay. So that's that part. Minus, and over here we've got 9 plus 18 is 27, minus 3 is 24. So 24 we can again write as 288 over 12. Okay, almost done. Pi, and then so we can combine this into, I'm going to do one extra step here. I'm just going to write everything down. 256 plus 288 minus 27 minus 288 over 12. All right, so we're getting pretty close to the answer here. Pi times, okay, the 288 and the negative 288 cancel. So 256 minus 27, that gives us 2, should we just take 20 away? That's 236, minus 7 is 229. So 229 over 12. Okay, so that's what we have. 229 pi over 12. Perfect. And I'm pretty sure this can't simplify any further, but if it can, yeah, it might be able to. I'm not sure. We don't want to leave it in terms of pi. I'm not sure if this calculator can simplify things. I'm probably not. Let's just check what is 229 divided by 12. Nah, I'm not sure. So if this is not the simplest answer, please let me know in the comments below, and I might update or at least put in something that says what the actual simplest answer is. Alright, so that is it for this question paper 2. And again, if you use any other methods, that's fine. Maybe something I can think of is over here, the area of the shaded region. What we could have done is we could have calculated the area of the curve, so x plus 3 over x, area underneath that curve, minus the area underneath the straight line. So that this is exactly the same as combining them into one. You can choose either method, that's fine, no problem. Okay, so again, please let me know if there's anything else, anything that I didn't explain adequately, or anything else that you just found interesting or want to know a little bit more about. Thanks for watching, and I'll see you again for the next video.